everyone, this is Kalpana here. In this video, we are going to solve the given differential equation. So let's get going. Problem: solve dy by dx minus y tan x equals to sin x into cos square x by y square. Solution: given differential equation, dy by dx minus y tan x equals to sin x into cos square x by y square. Consider the given equation as equation 1. Okay. Now, we can write the given equation as minus tan x into y equals to sin x into cos square x into 1 by y square. Right? We know that 1 by y power n can be written as y power minus n. Then we can write 1 by y square as y power minus 2. Right? Now, by comparing these two equations, that is the reduced equation with Bernoulli's equation, we can say that we have reduced the given equation to Bernoulli's form, right? Where P and Q, which is Bernoulli's in y and x. Here y is a dependent variable and x is an independent variable, right? Here P and Q are either functions of x alone or constants, and here you are having n, right? So here n is a real number such that n not equals to 0 and n not equals to 1. Here again, by comparing these two, we'll get P and Q, right? Which is Bernoulli's in y, and again by comparing these two equations we'll get P and Q. Consider the Bernoulli's equation as equation 2. Where P equals to minus tan x and Q equals to sin x cos square x. Again we have n equals to minus 2. Okay, since n is not equals to minus 2, n is not equals to minus 1, so we can say that this equation is Bernoulli's. Also we have the same form, right? Here the condition of n must satisfy. Fine. Now consider this equation. Now we have to reduce the equation 2 to linear equation. Okay. See, we got from Bernoulli's equation, we got P equals to minus tan x and Q equals to sin x into cos square x. This does not involve any other variable other than x, right? So we call these two functions as functions of x alone. Now we'll reduce the Bernoulli's equation to linear form, that is linear equation in y or something else. Okay, so again compare these two equations. We have dy by dx plus p into y equals to q into some function in y. But here we have p and q are either functions of x alone or constants, right? We don't have any other function other than q here, right? That is other than x, function of x or constant. We don't have any other function here, but we have y power minus 2 in the Bernoulli's equation. If we can eliminate this function from this Bernoulli's equation, then the equation can be reduced to the linear equation in y. So now we are going to eliminate y power minus 2 from this equation. So how we can eliminate y power minus 2? Simply by dividing on both sides with y power minus 2, or by multiplying on both sides with y square. Okay. So let's multiply equation 2 with y square. Okay. Either we have to divide the whole equation by y power minus 2, or we have to multiply with y square. So now we are going to multiply the above equation with y square. Equation 2 becomes y square times dy by dx minus tan x into y equals to sin x into cos square x into y power minus 2, right? The equation multiplied by y square in the sense, just multiply LHS and RHS by y square. Right? Then y square into dy by dx minus tan x into y square into y cube equals to sin x cos square x into y power minus 2 into y square. Here bases are equal, we'll add the powers. Y minus 2 plus 2 is y power 0. Again, y power 0 is 1. So this gets, that is, y power minus 2 gets eliminated. Right? Then we'll get y square into dy by dx minus tan x into y cube equals to sin x into cos square x. Okay, fine. So you can do all these process, or simply by looking at y power minus 2, we can directly multiply with y square into dy by dx minus tan x into y square into y is y cube equals to sin x into cos square x. We know that y square into y power minus 2 is y power 0, which is 1. Okay, we can write directly like this. Okay, or you can do all the steps. You can proceed all the steps, or you can write directly. Fine. Now, again, compare these two equations. See, we have the quotient of dy by dx y square, but we need to get quotient of dy by dx is 1. So we have to eliminate again y square. For that purpose, what we'll do is, we'll consider y cube equals to some u. Okay, we'll make a substitution. Not substitution. Let consider y cube as u. Right. Now, we have to differentiate it with respect to x. Okay. 3y square into dy by dx equals to du by dx. We can differentiate u with respect to x directly, or we can use chain rule to find the derivative of this with respect to x. We know that du by dx equals to, here we have function of y, right? So it involves differential dy into dy by dx. Now find du by dy. Since we have u equals to y cube, now differentiate on both sides with respect to y. Then we'll get du by dy equals to, derivative of y cube with respect to y is 3y square. Now replace du by dy with this 3y square, then we'll get du by dx equals to 3y square into dy by dx. So this is the actual procedure, but we'll do this in shortcut like this. Okay, instead of doing all this process, we'll directly do like this. So you're having 3y square into dy by dx equals to du by dx. Then now in the first term you have only y square into dy by dx, right? So we can take this 3 to RHS, then we'll get y square into dy by dx equals to 1 by 3 into du by dx. So when y cube equals to u, I'll get y square dy by dx equals to 1 by 3 into du by dx. Now this becomes, consider this equation as equation 3. Okay, this becomes, replace y square into dy by dx by 1 by 3 into du by dx minus tan x into, replace y cube by u equals to sin x into cos square x. Again, we are having quotient of du by dx 1 by 3. So we have to eliminate 1 by 3 here. What we'll do is, we'll simply multiply the whole equation with 3. Okay. Now multiply, consider as some equation 4 with 3. Then we'll get, with 3 in the sense, we'll multiply the whole equation with 3. That is, multiply equation LHS part with 3 and RHS part with 3. Then we'll get 3 by 3 into du by dx minus 3 tan x into u equals to 3 sin x into cos square x. Then 3 gets cancelled and you'll get du by dx minus 3 tan x into u equals to 3 sin x into cos square x, which is linear in u and x, right? Here x is considered as independent variable and u is considered as dependent variable. Now compare this equation with the standard form of linear equation in u. Du by dx plus p into u equals to q, right? Which is linear in u. Again, by comparing these two, we'll get p and q, where p equals to minus 3 tan x and q equals to 3 sin x into cos square x, right? Both p and q involves x and we don't have any other variable. other than x. So we call these two as functions of x alone, right? Now we need to find the integrating factor. We know that the integrating factor of linear equation u is given by e power integral p into differential dx. Equals to e power integral for p equals to minus 3 tan x dx e power, write the constant minus 3 outside the integral, you'll get minus 3 integral tan x dx. Since we know that integral tan theta d theta equals to log secant theta, then this becomes e power minus 3 log secant x. Again, you can write minus 3 log x as simply minus of 3 log secant x. Okay, you know that m log n can be written as log n power m, then you can write 3 log secant x as log secant x whole cube, which is secant cube x, right? Now we have e power minus log secant cube x is equals to e power log secant cube x whole inverse, that is reciprocal of secant cube x. We know that reciprocal of secant theta is cos theta. If you take power cube on both sides, then you'll get 1 by secant cube theta equals to cos cube theta. Then this becomes e power log reciprocal of secant cube theta is cos cube. Okay, reciprocal of secant cube x is cos cube x, right? And also we know that e power log some function of x equals to function of x, then e power log function of x becomes function of x. So we got the integrating factor cos cube x, right? Now we need to find the general solution to the given equation. So the general solution of the reduced equation, that is linear equation, will be the general solution to the given equation, right? Now we know that the general solution of linear equation u is given by u into integrating factor equals to integral q into integrating factor into dx plus c. Now using this formula, we'll find the general solution to the given equation. The general solution to the given equation is u into integrating factor cos cube x equals to integral q, for q equals to 3 sin x into cos square x into integrating factor cos cube x into dx plus c is equals to integral, take this 3 outside the integral, you'll get 3 into integral sin x cos square x into cos cube x is cos power 5x into dx plus c. We know that integral f of x power n into f dash of x into dx is f of x power n plus 1 by n plus 1 plus c, for provided n not equals to minus 1, right? Let us consider cos x. Let's write this as sin x into, I'll write cos power 5x as cos cos x power 5 into dx. Okay. Now consider f of x as cos x, right? Then f dash of x, that is derivative of f of x with respect to x, is derivative of cos x with respect to x minus sin x. So in order to apply this formula, we need a minus here. For that purpose, what we'll do is we'll include minus into minus, which is plus. Okay, we'll take one minus inside the integral and one outside the integral. Okay, this is equals to, you can just write this as minus 3 into integral cos x power 5, that is f of x power n into f dash of x into dx plus c, right? Now it's easy to apply this formula. See, f of x for f of x equals to cos x, power n for n equals to 5, and f dash of x for f dash of x equals to minus sin x into dx equals to minus 3 into f of x power n plus 1, that is for f of x equals to cos x minus 3 into f of x power n plus 1, that is cos x power n plus 1 for n equals to 5 plus 1 by 5 plus 1 plus c is equals to minus 3 into cos x power 5 plus 1 is 6 by 6 plus c. 3 ones are 3 twos are is equals to minus cos x power 6 can be written as cos power 6x by 2 plus c. Now replace u by y cube, then you'll get, so before replacing u, take this cos cube x to RHS. And this becomes u equals to 1 by cos cube x times minus cos power 6x by 2 plus c is equals to minus cos power 6x by 2 into cos cube x plus c by cos cube x. So here 3 cos x gets cancelled. Okay, then we'll get minus, or simply you can write cos x power 6 minus 3, which is cos x power 6 minus 3 is 3. We'll get cos cube x by 2. Okay, in the numerator you are having 6 cos x functions, and in the denominator you are having 3 cos x functions. Okay, we'll only cancel 3 cos x functions. Fine. Now this becomes 3 into you can write this as 1 by cos cube x. This equals to minus cos cube x by 2 plus c into reciprocal of cos cube x is secant cube x. Now take the LCM. You'll get 2 as your LCM. In the numerator you'll get minus cos cube x plus 2c secant cube x. Okay, now you can bring this to LHS, then you'll get 2 into u, 2u equals to minus cos cube x plus 2c into secant cube x. Now replace u by y cube, then you'll get 2y cube equals to minus cos cube x plus 2c secant cube x. You can conclude this as your general solution, or you can write constant 2c as c. Then if you consider 2c as c, you'll get c secant cube x. Okay. So this completes the problem. We have seen a Bernoulli's equation problem in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.